Good afternoon. This is Akanksha Shukla from IT department, and today I am going to discuss one of the most important topic of data analytics, that is time series analysis. Now, before moving towards time series analysis, let me introduce you about the time series data. So, the time series data is a data which we observed or record at a particular regular period of time, and time series analysis is a analysis which we performed to analyze that kind of data, and the data which we used or which we observed or which we record on the basis of certain interval of time, or we can say that on basis of a particular period of time, means monthly, seasonally, yearly. So, when we analyze the data on the basis of these time intervals, then that kind of data known as time series, and when we analyze these kind of data, then it is known as time series analysis. So it is a specific way of analyzing the sequence of data points which are collected over an interval of time, and in the time series analysis, analyst records the data points at a consistent interval of time over a set period of time here. Now, time series analysis requires a large number of data points to ensure the consistency and reliability, and also it provides an additional source of information over these dependencies between the data. Next is why organizations use time series data analysis. Basically, the time series analysis helps the organizations in understanding the underlying causes of trends or systematic patterns which are going to occur over the time, and with the use of visualizations method, business users can see the seasonal trends and can dig the deeper into why these trends occur. Now, I will explain what this term meaning, or what are the seasonal trends and what do you mean by trends in the next slides. Next, when the organization analyze the data over the consistent intervals, then they can also use time series forecasting to predict the likelihood of the future events. So, time series forecasting is a part of the predictive forecasting, and it can show the likely changes in the data like seasonality or cyclic behaviors, which provides the better understandings of the data variables, and it can help in forecasting better. Now, we can see various time series analysis examples, just like we are going to record the temperature of a patient for weekly or for in a day. So, this kind of data which we observed for a particular period of time can be considered as a time series data, and this analysis is termed as time series analysis. Okay, and many more examples are to identify the weather data, rainfall measurements, temperature readings, heart rate monitoring, brain monitoring, quarterly sales, stock prices, automated stock trading, industry forecast, interest rate, and at the time of COVID, we are going to monitor the oxygen levels of patients. Okay, so these type of analysis comes under the time series analysis. Okay. Next, what are the different types of time series analysis? First one is classification. Basically, this time series model identify and assigns the categories to the particular data. Means in classification, what we do for a particular data, we assign the categories, and we can say that we assign the classes for a particular data. Second one is curve fitting. In this, we plot the data along the curve, which can be able to study the relationship of the variables within the particular data. Next one is descriptive analysis. It identifies the patterns in the time series data like trends, cycles, or seasonal variations. Next one is explanative analysis. In the explanative analysis, we are going to understand the data in a deeper manner, and the relationship within that data, as well as the cause and effect relationship also. Okay, just like if we take an example that with doing exercise, we can do our weight loss. So, here the cause is, here we can identify the cause and effect relationship, that the cause is exercise, and it can be able to reduce the weight. So effect is weight loss and the cause is exercise. Next one is exploratory analysis. In this, we highlight the main characteristics of the time series data, just like in the visual format. Means by using pie charts or by using graphs, we can visualize the main characteristics of the data by using exploratory analysis. Next one is forecasting. In this, we predict the future data, which is based on the historical data or historical trends or past data, behavior of the past data. And in this, it uses the historical or past data as a model, by the help of which it can use to predict that data for the future data. Means based on the past data, it can predict the future data. Next one is intervention analysis. In this, it studies how a particular event or how different kinds of events can change the trend of the data. Last one is segmentation. In segmentation, what we do, we split the data into the segments that can be able to show the underlying properties of the source information from where we are collecting that information. Now, the time series data can be classified into two main categories. First one is stock time series data and second one is flow time series data. Whenever we are going to measure the attributes at a certain point of time, okay, then that data comes under the stock time series data. For example, if you are going to measure the data or measure the attributes that how many students come into the class at 9 o'clock. So, we are going to measure the attributes at a certain point of time. So, this kind of data comes under the stock time series data. And in flow time series data, we measure the activity of an attributes over a certain period of time. Okay. So, here if we for the same example, if we consider that how many students come into the class for a certain period from 9 o'clock to 10 o'clock. So, that kind of data comes under the flow time series data. Now, in time series data, variations can occur throughout the data. So, these variations can be classified into the following manner. First one is functional analysis. In the functional analysis, what we do, we pick up the patterns and the relationship within the data to identify the events or to identify the events which can be able to change the data. Second one is trend analysis. Basically, trend is a component of time series data which identifies or which is used to define the frequency changes in a particular data. Okay. So, it can be if we analyze the trend, then it means that determine the consistent movement in a particular certain direction. Okay. Next one is seasonal variation. Seasonal variation basically describes the events which occurs at specific and regular intervals during the course of a year. Okay. So, time series analysis and forecasting models must define the types of data which are relevant to answer the business questions, and once the analysts have chosen the relevant data that they want to analyze, then they can choose what type of analysis and what type of techniques are going to best fit that particular data. There are different types of data that describes how and when that time data was recorded. First one is time series data, which is already discussed, that the data which is recorded over the consistent interval of time is time series data. Second one is cross-sectional data, which consists of several variables recorded at the same time. Okay, so the data which consists of several factors, several variables, and that kind of data is recorded at the same time, then this is known as cross-sectional data. The last one is pooled data, which is a combination of both time series and cross-sectional data. Next one is what are the components of a time series data. First one is trend. Trend is basically, I had discussed that it is a general direction in which something is developing or changing. Means it is a component which is used to define the frequency changes in a particular data, and it can be in both the direction, it can be the upward or it can be also in a downward direction. Okay. Second one is seasonality variations. Basically, seasonality is often observed within a year or less, or it can be occur over the regular intervals. Just like if you take an example that we have a data of last 10 years, okay, suppose 1998 up to 2002, or we can take a 5 years data, okay, and here is the here is the detail of sales of refrigerator. Okay. So what we see that 1998 we have 20,000 sales, and in the next year we have 40,000 sales, and in the next year we have again 50,000 sales, means the sales of refrigerator goes down. Okay. So what we see that the changes or these variations in the data of sales of refrigerator goes downward. So what is the primary reason behind it? So what we do, we can analyze 4 components. First one is trend, second one is seasonal variation, third one is cyclic variation, and the fourth one is irregular variation. So here we can see that in the summer season there is an increasement in the sales of refrigerator in comparison to winter. So here the variation in the data comes under the seasonal variation, because the sales of refrigerator depends on the changes in the sales of the refrigerator depends on the seasonal variations, because in summer the sales of refrigerator will go upward, and in the winter it can be in the downward direction. Next one is cycles. So the variations in the data occurs due to the cyclic variations also, and these cyclic variations are of the business cycles, which comes under the peak, recession, depression and expansion. Suppose this is a normal line. So this graph represents the business cycle. Here this peak is known as the peak, here this is recession, and this is depression, and this is expansion. So if any changes, if the frequency of data in the last 5 years changes due to the cyclic variations. Okay. So suppose in the stock market or in the organizational behavior, we can see that if the data changes due to the changes in the business cycle, then that variation comes under the cyclic variations only. Next one is irregular fluctuations, irregular variations or irregular fluctuations. These variations are occur due to the sudden causes, and these causes are unpredictable, just like floods, earthquakes, COVID. Okay, so there is no any prediction about these kinds of natural calamities. So if the variations in the data occurs due to the sudden causes and due to the causes which are not predictable, then these variations come under the irregular variations only. Okay, so here the linear time series and analysis and non-linear dynamic methods are used. In the linear time series analysis basically is used to analyze the data that has a trend, and this equation defines the linear analysis model. Here yt is equal to the value of the data at time t, b0 is a constant, and b1 is the slope of that particular line. What is non-linear dynamic methods? Basically these methods are used for the model of the reconstruction of the time series, and this is performed by the method of delays only, and the time series can be represented as a series of a set of points. Here xt is such that xt is equal to xt comma xt minus 1 up to xt minus d plus 1 in a d-dimensional space. Means generally the real world problems comes under the non-linear methods or non-linear dynamic methods. So regression analysis are used, or time series data analysis are used to solve both the linear and non-linear problems that are existing in the real world problem. Now the next topic is rule induction. Basically in this process what we do, it is a kind of data mining process in which we are going to deduce the if-then rules from a given data set, and the symbolic decision rules which we explain, or which is capable to explain an inherent relationship between the attributes and the class labels in a particular data sets. Many real life experiences are based on this intuitive rule induction. Just like in the given slide, example is given that we can proclaim a rule which states that if it is 8 AM on a weekday, then the highway traffic will be heavy, and if it is 8 PM on a Sunday, then the traffic will be light. So these rules are not, we can say that these rules are not necessarily right all the time, that 8 AM weekday traffic may be light during a holiday season. But in general, these rules can be used or these rules hold true and can be deduced from the real life experiences which are based on everyday observations. Okay. So, the rule induction provides a powerful classification approach. And in a short, if we define the rule induction, then it is a technique which creates the if else then type rules from a set of input variables and a output variable. Here the example is given. The decision tree induction is given. Inside this, a training data set is given by computer. Here the classes or the columns are age, income, student, credit rating by computer. So, from this data, from this tabular data, we are going to deduce a decision tree. So, the root node is age. We can see that in the following table, there are 3 categories of ages. First one is less than equal to 30. Second one is 31 to 40. And the next one is greater than 40. Okay. Now, what we can see here in the table, that if the age ranges from 31 to 40, 31 to 40, 31 to 40, 31 to 40, then the by computer condition is yes. Yes, yes, yes. So, in the decision tree, what we do? We are going to add the next node, which is yes, means training data set is by computer. So, what we are going to deduce here? We are going to deduce the last outcome, that whatever the age is given, the by computer is yes or no. So, what we see in the table, that if the age lies in the range between 31 to 40, then by computer is yes. Now, less than equal to 30. In less than equal to 30, what we see? We see that if the student is no, then by computer is no. So, what we select, which attribute we select here? We select the student attribute, and if a student is no, then by computer no. If a student is yes, then by computer is yes. Similarly, in the age range of greater than 40, what we see? If the credit rating is fair, greater than 40, if credit rating is fair, then by computer is yes. So, what we select? We select credit rating as an attribute, and it is used to define the subnode of that particular node, and the second subnodes are excellent or fair. So, when the credit rating is excellent, then by computer condition is no, and if credit rating is fair, then by computer is yes. Here the ID3, I had used ID3. This is an algorithm which was invented by Ross Quinlan. So, their data set is following an example of this only. Next one is algorithm for decision tree induction. The basic algorithm, here we are using a greedy algorithm, and the tree is constructed on the basis of top-down recursive divide and conquer manner. At the starting of whenever we are going to start, or when we are going to design a decision tree, then all the training examples are kept at the root node, and then the attributes are kept categorical. After that, examples are partitioned recursively, and then test attributes are selected on the basis of heuristic or statistical manner. Now, what are the conditions for stopping the partitioning? When all the samples for the given node, which are going to belong to the same class, okay, are covered, then we have to stop. Then we have to stop doing the partitioning. Next, if there are no remaining attributes for further partitioning, then we have to stop doing partitioning. And last one is, if there are no samples left, then we stop doing partitioning. Now, using if-then rules for classification. Here, what we do, just like we can, just like from the given table, we can draw a decision tree. So, we can also represent the knowledge in the form of if-then rules. Here, the rule is from the decision tree or from the above mentioned table. The rule we formed here is, if age is equal to youth and student is equal to yes, then by computer is yes. Okay. So, the rule here has a assessment. The assessment is coverage and accuracy. So, N covers defines the coverage of the rule, and N correct defines the accuracy or correctness of a rule. So, N covered defines the number of tuples which are covered by that particular rule, and N correct defines the number of tuples which are correctly classified by that particular rule. Okay. If more than one rule are triggered, then there is a conflict, and to resolve that conflict we have to introduce the conflict resolution. So what we do size ordering, class based ordering and rule based ordering to resolve the conflict if more than one rules are triggered here. Now how to extract the rules from a decision tree? So basically rules are easier to understand than in comparison to if we are having a large decision trees. So one rule is created for each path from a root to a leaf node. Okay. Each attribute value pair along a path forms a conjunction and the leaf holds a class prediction. The rules which we formed are mutually exclusive and exhaustive. Example here is given, rule extraction from our by-computer decision tree. This is the by-computer decision tree, and from this decision tree we are going to extract the rules. So first rule is, if age is equal to young and student is equal to no, then by-computer is no. Means from root to leaf node, the rule indicates that if age is equal to young, means if age is less than equal to 30. What is the second line indicates that one rule is created for each path from the root to a leaf, and each attribute value pair along a path form a conjunction. Conjunction means and. So if age is equal to young means age is less than equal to 30 and student is no, then by computer is no. So this from root to leaf node, this one rule is created for each path from the root to leaf. Second rule is, if age is equal to young and student is equal to yes, means if age is equal to young and student is equal to yes. So this from root to leaf, this path can create another rule. So if age is equal to young and student is equal to yes, then by computer is equal to yes. Second rule is, if age is equal to mid age, then by computer is yes. From root to leaf, if age is equal to young, mid age means in the range of 31 to 40, then by computer is yes. Next one is, if age is equal to old and credit rating is excellent, if age is equal to old and credit rating is excellent, then by computer no. And the last one is, if age is equal to old and credit rating fair, then by computer is yes. So we can see here that from the decision tree how can we extract the rules if we are having a particular tabular data, or if we are having a decision tree, then that from that decision tree we can induct or extract the rules easily, and that rules are easier to understand than the large given decision trees. Here a sequential covering method or sequential covering algorithm is also used to extract the rules, but the sequential covering algorithm extract the rules directly from the training data. Okay, here many sequential covering algorithms are used, CN2, FOIL, AQ, Ripper, but in this methods what we see that here the rules are learned sequentially, and for a given class Ci will cover many tuples of Ci only, but none of the tuples of other classes. Means if you are going to extract the rules, or if you are going to learn the rules, or if you are going to design a rule, for then what in the sequential covering algorithm or in sequential covering method, for a given class, the tuples of a given class will cover the tuples of only that class, not of the another class. Okay. The rules or the steps are, what are the steps in the sequential covering method? First one is, rules are learned one at a time, means rules are learned one at a time, and each time when a rule is learned, the tuples covered by the rules are removed, and we perform or we repeat that process on the remaining tuples also until the termination condition will not occur. Okay, so these are the some basic steps which we use to induct the rule using the sequential covering method. Okay, thank you.